Swayam Prabha. Digital India. Educated India.
Okay, now let us going to discuss some more problem in Quasi-Newton method. I hope all of you know about that Newton method, and it is somewhat slightly differ from the Newton method, call it as Quasi-Newton method. If the function being minimized f of lambda is not analytic and it is closed form of its difficult to differentiate, the derivative f dash of lambda and f2 dash of lambda is equation. So, I plus 1th iteration of lambda is can be expressed lambda I minus f dash of lambda I by f2 dash of lambda I can approximated by the finite difference. So, the formula is f dash of lambda I equal to f of lambda I plus 4 lambda minus f of lambda I minus 4 lambda divided by, once again I tell you f dash of lambda I equal to f of lambda I plus delta lambda minus f of lambda I minus delta lambda by 2 delta lambda, and f2 dash of lambda I equal to f of lambda I plus delta lambda minus 2 f of lambda I plus f of lambda I minus delta lambda by lambda square, delta lambda square. So, that is the second derivative, where delta lambda is small step size, and substitute the above equation into lambda suffix I plus 1 equation. This leads lambda suffix I plus 1 equal to lambda I minus delta lambda into f of lambda I plus delta lambda minus f of xi minus delta lambda divided by 2 into f of xi plus lambda delta minus 2 f of lambda I plus f of lambda I minus delta lambda. So, this is the I plus 1th iteration of Quasi-Newton method. Now, where lambda delta is a small step size, and substituting the above equation into lambda I plus 1 equation, this leads to lambda suffix I plus 1 equal to lambda I minus delta lambda into f of lambda I plus delta lambda minus f of lambda I minus delta lambda divided by twice of f of lambda I plus delta lambda minus 2 f of lambda I plus f of lambda I minus delta lambda. So, the iterative process indicated by the above equation is known as Quasi-Newton method. So, to test the convergence of the iteration process, the following criterion can be used: modulus of f dash of x plus lambda I plus 1 equal to modulus of f of lambda I plus 1 plus delta lambda minus f of lambda I plus 1 minus delta lambda by 2 delta lambda, which is less than or equal to epsilon. Now, we are going to see the example. Find the minimum of the function f of lambda equal to 0.65 minus 0.75 by 1 plus lambda square minus 0.65 lambda into lambda tan inverse of 1 by lambda using Quasi-Newton method with the starting point lambda 1 equal to 0.1, the step size delta lambda equal to 0.01 in the central difference formula, and use epsilon equal to 0.01 for the checking of the convergence. So, the solution is iteration 1, here lambda 1 equal to 0.1 and delta lambda is equal to 0.1 and epsilon is 0.01. Therefore, f1 equal to f of lambda 1, lambda 1 is 0.1, is substitute it becomes 0.65 minus 0.75 divided by 1 plus lambda is 0.1 the whole square. So, it becomes 0.74257 minus 0.65 into lambda is 0.1 into tan inverse of 1 by lambda is 0.1. So, the value is 0.09562. Then 0.65 minus 0.074257 minus 0.09562 equal to minus 0.18819 and f plus f1 plus is nothing but f of lambda 1 plus delta lambda. So, f of lambda 1 is nothing but 0.1 plus delta lambda is 0.01 which is equal to f of 0.11. Therefore, substitute this in the equation 1, so that f of 0.11 is equal to 0.65 minus 0.75 plus 1 plus 0.11 the whole square minus 0.65 into 0.11 into tan inverse of 1 by 0.11. So, first one is 0.65, second simplify 0.74103 and third one 0.104478 equal to minus 0.195508. And similarly, f1 minus equal to, you have to decrement of lambda 1. Therefore, lambda 1 minus delta lambda is equal to lambda 1 is 0.01 minus 0.01, here 0.1. So, the net value is 0.09. Therefore, f of lambda 1 equal to f1 of f1 minus equal to f1 inverse of 0.09 which is equal to, first one is 0.65, second one is 0.74397, third one is minus 0.08664 and subtract them, we have minus 0.18061. Therefore, lambda 2 equal to lambda 1 minus delta lambda into f1 minus f1 plus minus f1 minus divided by 2 into f1 plus minus 2 f1 plus f1 minus lambda 1 is 0.1, delta lambda is 0.01 and F1 plus found out, this is F1 plus, this is F1 minus, substitute it, and then divided by 2 into F1 plus minus 2 F1 plus F1 minus, so which is equal to 0.1 plus 0.0014898 divided by 0.000524 equal to 0.3845. Now we have to check the convergency. So f dash of lambda 2 equal to modulus of f2 plus minus f2 minus divided by 2 delta lambda. So we have f2 plus and f2 minus, calculate it, and then apply here, you get to 0.12, f2 dash of lambda is equal to 0.127, which is greater than epsilon. Now the convergence is checked and the value is 0.127, therefore we have to proceed further. F2 equal to 0.65 minus 0.65340 minus 0.30084. After substituting, we have minus 0.30424. Now F2 plus here calculated. So f of lambda 2 plus delta lambda equal to f of 0.3945, and then substitute in the given function, it becomes 0.65 and minus 0.64899 minus 0.30643, and then subtract them, you have minus 0.3054, and similarly f2 minus equal to f of lambda 2 minus delta lambda, which is equal to f of 0.3745, which is equal to 0.65 minus 0.6577 minus 0.29514 equal to minus 0.3021. Therefore, lambda 3 equal to lambda 2 minus delta lambda to f2 plus minus f2 minus by 2 into f2 plus minus 2 f2 plus f2 minus, so which is equal to 0.3845 minus 0.001 into minus 0.3054 plus 0.3028 divided by 2 times of minus 0.3054 2 minus 2 times of minus 0.304 minus f2 minus is minus 0.30284, and simply add. So we have 0.3845 minus 0.40258 divided by 0.00044 equal to 0.4431. Now do like convergency, f of lambda 3 equal to f of 3 plus minus f of 3 minus by 2 delta lambda. So f3 you know, and f3 plus is lambda 3 plus delta lambda. So lambda 3 is equal to 0.4431 and then substitute here plus delta lambda is 0.01. So, 0.4531 and substitute in the given function we have minus 0.30957. Now, F3 minus is f of lambda 3 minus delta lambda equal to f of 0.4331 and which is equal to minus 0.30867. Therefore, lambda 4 equal to lambda 3 minus delta lambda into F3 minus F3 dash divided by 2 F3 plus minus 2 F3 minus F3 dash, and already we found F3 plus F3 minus. Substitute here and the net value is 0.445 which is greater than epsilon, not nearing to 0. Therefore, further proceed. This implies lambda 4 equal to 0.4431 minus 0.01 into this value, substitute it, and corresponding these two value also substitute. So, we have F4 equal to 0.65 minus 0.5975 minus 0.3622 equal to minus 0.3097. Then F4 plus is 0.65 minus 0.59268 minus 0.6671 which is equal to minus 0.30939, and F4 minus is 0.65 minus 0.6023 minus 0.3576 equal to minus 0.3099. Therefore, optimum solution at lambda star equal to lambda 4 equal to 0.5052. Now, we have another example. Find the minimum of the function f equal to lambda by log lambda by cubic interpolation method, taking the initial step size length 0.1. Now, we have a solution f equal to lambda by log lambda, differentiate with respect to lambda. So, denominator square into denominator into d by dx of numerator to numerator into d by dx of denominator. Therefore, the resultant is log lambda square, log lambda to lambda differentiation 1 minus lambda keep as it is, log of lambda is 1 by lambda. So, lambda lambda get cancelled. So, log lambda minus 1 by log lambda the whole square. Now, you take A equal to 0 and lambda equal to 0 initially. Therefore, df by d lambda at t equal to 0 equal to 0. To find B at which df by d lambda is non-negative and t naught equal to 0.1. So, f dash of t naught equal to 0.1 is minus 0.6229 and f dash of 2 t naught equal to 0.2 which equal to minus 1.0073 and f dash of 4 t naught equal to 0.4 is minus 2.2824 and f dash of 8 t naught equal to 0.8 equal to minus 24.56 and f dash of 16 t naught equal to 1.6 equal to minus 2.399 and f dash of 32 t naught equal to 3.2 is minus 0.1 12059. Now we got the value of what? B, FB and FB dash. So, B equal to 3.2 and substitute in the function we have 2.7511. So, FB dash is equal to differentiate of the function and substitute log t minus 1 divided by log t the whole square is FB dash equal to 0.12059. Already A is 0, therefore, f of A is 0. Obviously, f dash of A is also 0. So, making use of this function values and take into the iteration 1 z equal to 3 into f of A minus f of B by B minus A plus f A dash plus f E dash. So, which is equal to 3 into minus 2.7511 divided by B minus A is 3.2, f A dash 0, f B dash is 0.12059. So, we have minus 2.4. Therefore, Q is equal to Z square minus f A dash f B dash whole power half, and then Z value is minus 2.4. So, minus 2.4 the whole square and f A dash is 0 and f B dash is a value of 0.12059, substitute it and take the whole power half. So, 2.4585 is a Q value. Therefore, lambda star equal to 0 plus minus 2.4585 minus 2.4585 into 3.2 divided by 0.12059 into 2 into 2.4585. So, which is equal to 1.64. Therefore, f dash of lambda star is equal to minus 2.0648. Now, iteration 2, f dash of lambda star is less than 0 and A equal to lambda star. So, we found the value of A and then f of A dash, B, FP and FP dash. So, we got all the values. Now, according to the definition of the formula Z equal to 3 into 3.315 minus 2.7511 divided by 3.2 minus 1.64 minus 2.0648 plus 0.12059, which is equal to minus 0.8597. Therefore, the Q value equal to 0.99402. Now, we have a lambda star. Lambda star, we have the formula of lambda star is equal to A value. Here A value is 1.64 plus corresponding f A dash and then minus Z plus or minus corresponding the values of f B by B minus A plus f A dash plus f P dash. So, that substitute the values of these 3 into B minus A by f A dash plus f B dash minus 2 times of Z. So, we have 2.462. Now we calculate f star of lambda star equal to minus 0.129. Now check it out the value. It not reaches 0, therefore go to the iteration 3. So f dash of lambda star is less than 0 and a equal to 2.462. So a 2.462 and b is 3.2. Therefore fa equal to 2.732, fb 2.7511. So fa dash equal to minus 0.1219, fb dash is 0.12059. Therefore z equal to 3 into 2.732 minus 2.7511 by 3.2 minus 2.462 equal minus 0.1219 plus 0.12059 equal to minus 0.07815. Now q equal to 0.14468. Therefore lambda star equal to 2.462 plus fa dash minus z plus or minus q divided by fa dash plus fv dash minus 2 times of z, numerator b minus c. So that simplify, we have lambda star equal to 2.722. Therefore f dash of lambda star equal to 0.0136. Now based on the secant method, the iterative process can be implemented by using the following step by step procedure. Set lambda 1 equal to a equal to 0, evaluate f dash of a. Therefore the value of f dash of a will be negative. Assume the initial trial of step length t naught, set I equal to 1, evaluate f dash of t naught. If f dash of t naught is negative, then a equal to lambda I equal to t naught, f dash of a equal to f dash of t naught, and new t naught is 2 t naught, and go to step 2. So if f dash of t naught is negative, set b equal to t naught. Therefore f dash of b equal to f of t naught, and go to step 5. Find the new approximate solution of the problem lambda suffix I plus 1 equal to a minus f dash of a into b minus a by f dash of b minus f dash of a. And for the testing of convergency, modulus of f dash of lambda I plus 1 less than or equal to epsilon, where epsilon is a small quantity. If the equation is satisfied, take lambda star equal to lambda suffix I plus 1 and stop the procedure. Otherwise go to step 7. If f dash of lambda I plus 1 is positive, set new b equal to lambda suffix I plus 1, then f dash of b equal to f dash of lambda I plus 1, where I equal to I plus 1, and go to step 5. If f dash of lambda suffix I plus 1 is negative, and set new a equal to lambda plus I plus 1, and f dash of a equal to f dash of lambda I plus 1, where I equal to I plus 1, and go to step 5. Now we have an example. Find the minimum of the function f of lambda equal to 0.65 minus 0.75 by 1 plus lambda square minus 0.65 lambda into tan inverse of 1 by lambda. Using the secant method, with an initial step size T naught and lambda 1 equal to 0 and epsilon equal to 0.01. Now we have a solution lambda equal to 0, which is equal to A choose, and step size is T equal to 0.1. Therefore, f dash of lambda equal to differentiate of equation 1. Therefore, 1.5 lambda by 1 plus lambda square the whole square plus 0.65 lambda by 1 plus lambda square minus 65 lambda square 1 by lambda, and put lambda equal to A value is 0. Therefore, the above f dash of A equal to 0, and B, f of B. So, B is nothing but A plus T naught, and A is 0 and T naught is 0.1. Therefore, B equal to 0.1. Therefore, f dash of B equal to 0.1470 plus 0.06435 minus 0.9562. So, the net value is minus 0.74481. Since f dash of B is negative and A equal to 0.1, therefore, f dash of A equal to minus 0.74481. Here T naught is 0.1 and multiply with 2, so 0.2. Therefore, B equal to x1 plus T naught equal to 0.2. Now, you know f of lambda and f dash of lambda, and lambda equal to B you are substituting, therefore, f dash of B equal to 0.27736 plus 0.125 minus 0.8927, which is equal to minus 0.49034. Since f dash of B is negative and set nu equal to A equal to 0.2, therefore, f dash of A equal to minus 0.49034, and go to the next step size A1 plus T naught equal to B equal to 0.4, and f dash of B equal to substitute this value in f dash of lambda, lambda equal to B, so that we have negative 0.10366 will come. Since f dash of B is negative, set nu A equal to 0.4. So, f dash of A equal to minus 0.10366. Here next step size is 2 into T naught, that is 0.8. Therefore, B equal to 0.8. Instead of lambda equal to B, f dash of B equal to 0.180608. Since f dash of B is negative and we proceed to find lambda 2, therefore, we have iteration A equal to lambda 1 equal to 0.4. Therefore, f dash of A equal to minus 0.10366 and B equal to 0.8. Therefore, f dash of B equal to 0.1808. Therefore, lambda 2 equal to A minus f dash of A into B minus A by f dash of B minus f dash of A, and A value we got it 0.4 and f dash of A value already we know, and then f dash of A we know, f dash of B we know, and then B we know, and A we know, and f dash of A also we know that. Substitute it, we have a 0.4 minus 0.10366 plus into B minus A 0.8 minus 0.4 by 0.180 plus 0.10366, which is equal to 0.54576. Now the convergence is check. So, f dash of lambda 2 equal to 0.486 plus 0.2733 minus 0.69628, which is equal to 0.06302. Now we have iteration. F dash of lambda 2 equal to 0.0603302 is positive. So we set a new A equal to 0.4 and f dash of A equal to minus 0.10366 and B equal to lambda 2 equal to 0.54576. Therefore, f dash of B equal to 0.06302. Therefore, lambda 3 equal to A minus f dash of A into B minus A by f dash of B minus f dash of A. So, A equal to 0.4 and f dash of A is minus 0.10366 into B minus A by f dash of B found out, substitute, and then f dash of A found out, substitute it. So, that 0.49064 will come and check the convergency. So, we have the value of f dash of lambda 3 equal to 0.01057. Therefore, lambda star equal to 0.49064.